it means that if the electron present inside this metal required high energy, then classical physics say that a light will fall on this metal, okay, for large amount of time, for huge amount of time, huge amount of time, and when an electron will continuously absorb energy. When light fall on this electron will continuously absorb energy. So time will go on. Okay, it will continuously absorb energy, absorb energy. And when the energy of electron is greater than the work function of this metal, then electron will leave this metal and will go out.
Yeah.
Okay, this is the classical physics. So
in the book it says energy is quantized. What does that mean?
Yeah, I am coming toward that. Actually, Planck say that there is a difference between the classical contradiction between classical physics and Planck theory. Okay, forget the Newton. Okay, sorry, Einstein. Okay, forget that thingy, Einstein law and photon and etc. Okay, Planck said that if the frequency is greater than threshold frequency, then when it fall on metal surface, then it will instantly eject an electron. Okay, but classical physics say that no, it will not instantly eject an electron. But when light fall for a huge amount of time, then electron will get energy, will absorb energy continuously, and when the energy of electron is greater than the work function, then electron will be ejected from the metal surface.
When the electron gets ejected, does it get excited so it goes up and then goes back down, or does it eject permanently?
No, it will eject permanently.
Oh, so it's ionized.
Yeah, it will ionize. Yes, it will get ionized. And also there is one more point, another point, that is the work function is the, okay, in metal we have valence band, we have conduction band. This is related to the question which you sent me in last class. This is the conduction band. Okay, and as we know that in metal, okay, we have lots of electron like this. Okay, so this electron will require less energy to eject from the metal surface as compared to this electron. When light fall on it, then this electron have no other repulsive force, so that's why it will easily leave this metal and will get ejected.
Yeah.
But when light fall on this electron, then it will take energy greater than the energy of this electron, because there is also a repulsive force. Okay, so there is also a repulsive force of the surface electrons. Okay, upper electrons. So that's why he will require a greater energy to leave this object. So this electron, which is E2, and let's say this electron is E1. So energy required by the electron E2 will be greater than the energy required by electron E1. And similarly, if electron is present over here, then this electron required energy greater than the E2 and E1, because there is a lots of repulsive forces. So to minimize that repulsive forces, he will require lots of energy. So, and that energy is greater than E2 and E1, and then he will get ejected from the metal.
Oh, that I know. You're talking about the question I gave you. The question was,
yeah.
Why?
Wait. But there is another question, and the question is, then why every metal has a unique work function?
Because it depends on the material.
Yeah, it is a difference of the material, but here, as you see, electron is ejected but require different energies. The
electron is higher up, so it's easier.
No, actually, what is the definition of work function?
I don't know. Oh, the minimum energy required for an electron to be ejected from the surface of the metal.
Yeah, the minimum energy required for an electron to eject from the. So, but here the electron required different energies, and the work function of this metal is unique. Let's say 4.4 electron volt. This is the work function of this metal. Then this energy required different energy. This also, if this electron want to eject from the metal, then it requires different energy, and that energy is greater than this energy, and this requires different energy that is greater than this energy. So what is your thinking?
Because the deeper down you go, the electron will be closer to the nucleus.
Yeah.
It requires more to be removed. So when the photons will have different energy as well. So.
Yeah, photon will have one energy. Photon has energy that is HF. Okay, and so 4.4 electron volt is the work function of this metal. So 4.4 electron volt is the energy of this electron, or this electron. First one, second one, or third one?
Third one.
Third one.
Sorry, first one.
First one, as you said that it is the minimum energy required. It is the minimum energy required. Okay, so this energy is the greater energy. So minimum energy is this. It means if you decrease the energy.
Wait. If this is the minimum energy, then it has to be that one.
Yeah, it has to be that one. It is that electron. It is the energy of that electron which is present in the conduction band.
This one.
Yeah, or you can say that electron which is present in the conduction band,
Yeah.
not the valence band.
Oh.
Okay, so work function is the minimum energy. It means it is the energy required by the conduction electron. You can say like this.
Oh. Not the valence ones.
Yeah, not the valence one. But if you increase the energy greater than 4.4 electron volt, then this electron will also get ejected.
What?
If you increase the energy 4.4 electron volt, greater than 4.4 electron volt, okay, let's say 6 electron volt.
Yeah.
So these electrons will get ejected. Okay, and all these electrons will have same kinetic energy.
Yeah.
But the question is, you will get a range of frequency, range of kinetic energy. So it means that some electron is also ejected from the valence shell.
Yeah.
Okay, and this required greater energy. Let's say this electron required 4.4 electron volt energy, and let's say this required 5 electron.
Yeah.
So the kinetic energy will be equal to 1.6 for this electron. 1.6. Yes, and this will be 1 electron, 1 joule. Okay, kinetic energy will be for this valence, it will be 1, and for this it will be 1.6. So there is a difference in the kinetic energy of electron coming from the same metal. So that difference is because some electron.
I'm confused.
Okay.
I don't understand why it's 1.6 and 1.
Actually, last time we discussed that the energy of photon is equal to the work function. Okay. Some energy will lose in the work function, plus the lefted energy will be the kinetic energy of that electron.
Yeah.
So when 6 electron would fall on this metal, okay, so and the work function of this metal is 4.4 electron volt. It means that the conduction electron will require 4.4 electron volt energy. So if the conduction electron requires 4.4 electron volt energy and this photon energy is 6 electron volt, then the kinetic energy that will be equal to 1.6 electron volt.
Yeah.
And
Oh.
and these electrons required energy that is greater than the conduction electron energy. That is greater than the energy required by the conduction electron. And let's say that is 5 electron volt, greater than 4.4 electron volt. Okay. So it will require how much kinetic energy? 1 electron volt kinetic energy.
Why?
Because for ejecting from this metal surface, it will require 5 electron volt. Okay. So here you will get 5 plus kinetic energy, and here we have 6 electron volt. So kinetic energy of the valence shell electron will be equal to 1 electron volt, which is different from the 1.6 electron volt. So you get a range of kinetic energy, 1 to 1.6.
I remember the question you're talking about. The question was why do you get a range of kinetic
Yeah,
energies?
yeah. Why you get actually we discussed that all electrons which ejecting from the metal will have same kinetic energy. We discussed this.
Yeah, but that's wrong.
No, that is if you get one if you get one kinetic energy, okay, same kinetic energy, all electrons ejecting from this metal surface have same kinetic energy, then it means you are ejecting electron from the conduction band, not the valence band. But if there is a range of frequency, then it means you are ejecting electron which is present at the surface plus electron which is present beneath that these electron.
No.
Got it?
So you know when we draw energy level diagram like this, for example, this will be 5. Wait, like this is 5, 4.4, for example. How would you differentiate the valence band and the conduction band? Like, will this be the conduction band, and this will be the valence?
Yeah, this will be the conduction band. Here you will have one electron, like in sodium. Here we will have one electron, and in chlorine, you will get a deficiency of one electron. and this shell will be filled up by electrons.
Oh, you don't need to draw any of that. Wait, clear that. My teacher said you only need to draw arrows, so it will go like this, then it will go like, sorry, it will go like this, and it will go like this. And
So this
excitation.
excitation, de-excitation.
I don't know, whatever. Clear that up.
Actually, we will discuss that later on in this chapter. We also discuss the Bohr model, okay? But that will be after this, all these effects. We also discuss the ionization. We will also discuss the excitation, de-excitation. But you get that what is ionization? It is simple, okay?
How does ionization link with excitation?
Actually, in ionization, there is a loss of electron.
Yeah, I know that.
And in excitation, there is no loss of electron.
So you know when the work function is the minimum amount of energy required to eject an electron, is that electron being ionized or excited?
That electron, that means that the electron being, ionized, that the electron being ionized.
Okay. So what is excitation? What's it used for? And like, how does it link to the circuit?
Wait. Actually,
Okay, we get.
no. Actually, if the atom is stable, okay, if the atom is stable, then it means it has equal number of positive charge and equal number of negative charge.
Yeah.
Okay, but if it lose one electron, then it has 5 positive charge and 4 negative charge. Positive charge is greater than negative charge, so positive charge will come on this atom. It means that it has greater positive charge than the negative electrons.
Yeah.
Okay, but if he get one electron, if he get electron, then this, if he get electron affinity, then that will be -6. Okay, 5 -6. So negative charge come on this atom. It means that he has one extra electron.
Yeah.
Got it? And this
What is this?
And okay, this is the atom.
Yeah, I know that, obviously.
Yeah, this is the atom, and this has positive charge, this has negative. When you combine these two, then 5 plus 5 is 10. Okay, -4 -6 is -10. So atom will get stabilized. So that's why this will be your molecule. Because in atom it will not exist. It's just, yeah, it will be unstable. This will be unstable. This will be unstable.
But these are two different molecules.
This is not molecule. This is atom. This is atom. This atom is stable. This atom is also stable. But when he eject electron, then it get unstable. And this is
so this is how alpha decay and beta decay.
Yeah, that is actually something else. Alpha, beta, gamma. That is the radiation.
Yeah. If you why teaching me radiation? Oh my gosh! Skip this. This is not in the topic.
Actually, you talk about the ionization and excitation. So
no, I'm talking about it in terms of quantum physics. Look, I'm saying, wait, go next page. Just ignore this. Ignore this. I'm saying, what is excitation? What is de-excitation? And what's the difference between excitation and ionization?
Actually, in
when does it occur?
If electron get energy, and that energy is equal to the work function, okay, then this electron will leave this atom. Got it? That is the ionization. But if this electron get energy, but that energy is less than the work function, then this electron will get excited and it will come to the upper shell. But after microsecond, it will come back to its home and release energy. That energy which we get to move from here to here.
So this energy, is it light?
Yeah, it will eject energy in the form of light.
So is it used for LED?
Yeah.
What about a normal circuit? Is it used in normal circuit?
Normal circuit?
Oh, I don't know, leave anyway. Ignore me.
Okay, so classical physics said that no matter if the frequency is greater than or less than, but if the intensity is high, then high number of electrons will get ejected. Okay, and that the process will not be instantaneous, like as the Planck said. Okay, classical means all the theories which is present before Planck theory.
Yeah,
we are studying from Actually, Planck don't know in Planck in which sun.
Yeah, I know what you're talking about. Don't worry.
Yeah, so that is the classical physics. Okay, but when he discovered this law, then all scientists get surprised that what is talking about. That if the intensity is if the frequency is less than the threshold frequency, and if you increase the intensity, then electron will not eject it. But classical physics say that no, it will eject it. No matter what will be the frequency, it will eject electron. And intensity is equal to the energy per unit time. Okay.
So if you increase the number of photons that are coming to the conduction band, then the electron will not be ejected.
Yeah.
Classical physics said that it will be ejected like that.
Classical physics say that if the intensity is high, then the electron will get ejected. But if the intensity is not high, then it will take lot of time. It will take lots of time. And when the energy is greater than the threshold work function of the metal, then the electron will get ejected.
Oh, but this is not true because energy is quantized.
Then Einstein said that energy is quantized. I said that forget all the theories which all the points which Einstein said. Now just think about this, that because now Einstein is not existing.
He's not present.
It's not present. It's not, yeah, and not present. Okay. So
yeah, I get it.
Okay, and
now let's move on to Einstein because he came along, so we can't ignore him.
Yes. Okay, we will continue him.
Oh, Einstein's so clever.
Okay, but Planck said that no, if the frequency. Okay, Planck said that this, and also he talked about the time. He said that if the frequency is greater than threshold frequency, and when light fall on metal, okay, then electron will instantly eject out from the metal surface, and the time even within less than 10 to the power minus 9 seconds, it will get out from the metal surface. Okay, it will not wait to absorb energy, and if the energy is greater than the work function, then I will come out from the metal surface. No, if the frequency is greater than threshold frequency, and when light fall on this electron, then instantly, like in 10 to the power minus 9, even less than this time, even less than 10 to the power minus 9 seconds, electron will get ejected from the metal surface.
Oh, so it doesn't take a lot of time because one photon, so one packet of energy, has to have energy greater than the threshold work function. One packet. This is one photon.
Don't talk about the packet of energy. Photon, Einstein is absent. Now,
but I'm talking about Einstein.
Yeah, okay, I am coming toward there.
Okay, fine. You're taking so long to go to Einstein, that's why.
Actually, I want to clear all the points, not like the last one, which I left one point. So that's why I want to clear all the points. Okay, and Planck also said that the stopping potential, okay, that is the directly proportion to the frequency of the incident photons, incident radiation. So sorry, you will not use the term photon. Okay, incident radiation.
Yeah.
Okay, Planck said that the stopping potential.
What's the definition of stopping potential? It is the voltage when the electron becomes static.
Yeah. Okay, if the frequency is greater than the threshold frequency, then the stopping potential, or you can say that the maximum kinetic energy, because through stopping potential you will get maximum kinetic energy.
Yeah.
Of the photoelectron, stopping potential or okay, write this: stopping potential or maximum kinetic energy. In bracket, also write this: that EV0 is equal to 1 divided by 2 mv max square.
Oh my god.
Last time we did this.
Yeah, you're right.
Okay, the stopping potential or the maximum kinetic energy of the photoelectron is directly proportional to the frequency of the incident radiation.
Yeah, this is what Planck said.
Yeah, Planck said, but it's independent of its intensity.
Oh,
stopping potential will not depend on the intensity.
Oh, why?
If the intensity is high, then the number of electrons ejected from the metal surface will be high.
Yeah, so the stopping potential will increase.
No. Actually, all electron ejected will have same kinetic energy. So if all electrons have same kinetic energy, then the stopping potential will be same.
Oh, okay.
Also, note all these so that later on you do.
Oh my gosh, I'm not noting anything down. I forgot.
Okay. Okay, now let's come toward the Einstein.
Okay, just write the important points on the PowerPoint. I'll copy later. Finally, Einstein.
Yeah, Einstein. Okay, so Einstein said that the photoelectric emission is the result of the interaction of two particles. Okay, one is the photon. He said that is the photon, not the radiation. That is the photon.
Wait, what's the definition of photoelectric emission? Because in my exam they ask.
Actually, when photon interact with metal, so it will emit electron.
Oh, okay.
That is the photoelectron emission.
Okay.
Or it will emit electron, and electron are moving with kinetic energy. And as electron is moving, so current will produce. So photon electric emission.
Yeah.
You can say like this. So photoelectric emission is the result of the interaction of two particles. One is the photon of radiation, and other is the electron of the metal. Okay. Okay. So photon. Einstein also said that the minimum energy required to eject an electron is called the work function. Okay. Einstein said that. Okay, so that is photon. In this one, photon plus electron.
Yeah.
Okay, and interaction of photon plus electron result photoelectric emission. Second point is this. That the work function. Okay, he explained that it is the minimum energy required to eject an electron. Third point is each photon when interact with one electron. Okay, each photon. Einstein said that the radiation is not continuous. It is in the form of discrete packet. It will flow in the form of discrete packet. Okay, and each packet has energy that is equal to hf. Got it? And this
Yeah,
is
because light has different wavelengths, so different frequencies, therefore different protons, right?
So this is one photon. Okay, and one electron will absorb completely one photon. It is not like 0.5 electron, 0.5 photons, 0.6 photons. Okay, it is quantized. It is quantized. One photon, two photon, three photon, four photon, five photon. Not like one photon, 0.5 photon. So 1.5 photon, 0.7 photon, 0.8. It is quantized in the form. So one electron will absorb completely one photon.
But different photons have different energies.
It depends on light. If your light is red, okay.
Yeah. If it's UV light, it has mixture of.
Yeah, mixture, then it will have different energy. Then photon will have different energy.
Yeah.
Okay, so so Einstein said it is not the radiation. It is in the form of quanta. Okay, packets of energy, and each photon and each electron will absorb one photon completely. Okay. Okay, and Einstein said that if you want to increase the number of photons, okay, if you want to increase the electron ejecting, okay, then you need to increase the number of photons. Increase the number of photons. Okay, and if you increase the number of photon increase, it means you are increasing the intensity. So then the number of electron ejecting will be greater number of.
That's not true though. That's Planck's.
How it is not true?
You said if the intensity increases, it doesn't affect. You said if the intensity increases, it will take less time to be ejected. That's not true. It will take the same time regardless. Right?
No, in classical physics, it will take the same time. Planck said that it will not take the same time. It will be instantly. The process is instantaneous, simple.
Yeah, that's true.
But classical physics said that the process is not instantaneous.
Yeah, wait.
And that is true. That is true. The process will be instantaneous.
Yeah, exactly. But who is right, Planck or Einstein?
Einstein also said that the process will be instantaneous.
So Planck and Einstein said the same thing.
Yeah, he said the same thing, but Einstein did not arise this point that the process will be instantaneous or not.
Oh, so there's two scientists, Planck and Einstein.
Yeah, actually, Einstein proved the Planck theory. He did not say that Planck is wrong.
Oh.
He just explained it further. He take the Planck theory, okay, Planck concept, and explain it further, and also clarify it more to the other old scientists.
Oh, he clarified the Planck's theory because Planck didn't have evidence to back it up.
Yeah, he clarified that theory to the old scientists, okay, classical physics, okay. So that's why he get a Nobel Prize on this. Actually, he did. Actually,
Let me see how
Planck bring a confusion in old theories and in his theories.
Yeah, because Planck said that it happens instantly, but the classical physics said that it takes time depending on the intensity.
Yeah, depending on intensity, yes. And it will not depend on the frequency. Classical physics said that. But
Yeah.
Planck said that it will depend on the frequency. And even Einstein also said that it will depend on the frequency, okay? And if you want to increase the, and he said that one photon when piled on metal, then it will eject one electron. Okay, because one electron will absorb that one photon. So if you
it can't absorb two photons.
yeah, and question will be like this: if 16 photon, if I want to fall 16 photon on metal surface, okay, then find this. So numerical will be like this. So there you will use 16 photon. So the energy of 16 photon will be equal to 16 times HF.
Wait, what?
If the question is 16 photon, let's go to one. 16 photon fall on metal. Find dash. Okay. So 16 photon means 16, and the energy of one photon is HF.
So it says, what is the question? Find the total energy incident on the metal conductor.
Yeah, question will be like this, but you must understand that what is mean by 16 photon. You will not take like this is equal to HF. That is the energy of one photon. Or 16 photon.
Oh, no. Yeah. E represents energy of one photon. H
one photon, yes. And this is, and Einstein tell us this.
He's so smart.
And Einstein said that one photon will interact with only one electron.
Yeah.
Not two electron, okay? It will interact with only one electron. So one electron will either absorb all this one photon energy, okay, or it will not absorb all the energy. But it will absorb all the energy, sorry.
Yeah.
And Einstein said that if the photon energy one photon energy is greater than the work function, then this electron will get ejected.
What about classical physics? Classical physics said that.
Classical physics said that if the energy of photon is less than the work function, then it will take a huge time, and then electron will get ejected.
Oh, that's not true. That's not
true. Yeah.
What about E equals mc squared? What's that?
That is actually
something else.
Yeah, something else.
Okay.
Actually, through that you can find the energy of light if you know the mass.
So energy of all the photons.
Yeah, energy of all the photons. Yes.
Okay, let's do exam questions.
Okay, wait. We need to finish this Einstein points. Okay. Okay. So the okay, another point is actually this is second point. This will be the third point. I will send you on this slide. Third point. And the fourth point is that Each photon interact with one electron. Okay, got it? Each photon interact with one electron, and the energy HF, which is HF, of the incident photon is used in two part. Okay, energy HF of the incident photon is used in two part. One part of energy of photon is used to eject electron, that is the work function.
And one is used to accelerate it.
Yeah, and another one is used to accelerate it.
Yeah. I like quantum physics. It's interesting. I don't like waves anymore.
Yeah, it is interesting. Okay, and work function is HF naught. F naught is the threshold frequency. Threshold frequency. So your HF will be equal to HF naught plus 1 by 2 mv max square. Okay. You can write it like HF minus HF naught, that is equal to 1 by 2 mv max square. You can write it like HF minus F naught is equal to 1 by 2 mv max square.
Is it always V max?
Yeah, V max, actually maximum kinetic energy. We will require maximum kinetic energy you will get.
How do you know it's maximum kinetic energy? What if what if there's another electron with greater energy?
No, all electron will have same kinetic energy.
No. On the valence band.
Okay, Venus band. Okay. So maximum kinetic energy will be the energy of electron, which is present in the conduction band. Not the energy of kinetic energy will not be maximum for the valence band electron.
So this equation relates to the conduction band.
Yes.
Okay.
Yes. This will be very right. This is very important point. Good. It is valid for only conduction band electron.
I speak so much. Oh my gosh.
Huh? Conduction band electron. This is very interesting, a very good point which you arises over here.
Thank you.
Okay, so now this is the final equation, and this equation will tell us everything. Einstein gave us this equation, and from this equation, Einstein explained this theory a bit more. He said that if the frequency of the incident photon is less than the threshold frequency, then Planck said that no electron will get ejected. Got it?
Yeah.
But he not explained that quantitatively. But Einstein said that means that your kinetic energy will be negative.
Oh.
So it means no ejection of electron. This
What
is
is that?
Einstein.
How can the kinetic energy be negative?
Kinetic energy negative means it is you can say like potential energy will get increased. Energy is potential plus kinetic.
Okay, let's do exam questions now. Let me send you.
Okay, wait, there is few points. Okay, also send me that. We will do that. Okay.
No. First finish it. Otherwise, we can't do all the questions.
Okay, so there are only 2 points I want to explain that. Then we will do that. Okay.
Okay, go next slide. Otherwise, it's too much in one page. I can't revise.
Okay. The equation was H F minus F naught, that is 1 by 2 mv max square. Got it? And if the frequency is less, then the kinetic energy will be negative. If the frequency is equal to threshold frequency, then the energy of the incident photon will eject electron, but the electron will not have kinetic energy. And that is the work function. Is the work function. Got it?
Yeah.
So all these beautiful points explained by Einstein. The third point is,
Wait, go to the previous point. I don't understand this.
this one.
Previous page. Yeah.
It means that electron will not be ejected, but simple. It means this.
So it will be stationary.
It will be stationary, remain stationary.
Okay, next page.
Okay, if the frequency is greater than, if the frequency is equal to the threshold frequency, okay, then kinetic energy will be equal to 0. And this is
No, it will still be ejected. It will still be ejected, the electron. If frequency is equal to threshold frequency, the electron will be ejected, but the kinetic, it won't accelerate. It will be constant.
It will be constant. And what is work function?
Constant speed. Work function is the minimum energy required to be ejected.
Yeah, so that is the work function.
Okay.
Another point is that if the frequency is greater than the threshold frequency, then you will get a kinetic energy.
Yeah, we know that. That's easy.
And that kinetic energy will be directly proportional to the frequency.
Yeah.
And he also tell us about the time, Einstein. He said that actually photoelectric emission is the result of the elastic collision between photon and electron. Okay.
To create current.
Yeah. So the absorption of energy from a photon by free electron in a single event, okay, which involve transfer of energy in one lump instead of continuous absorption of energy.
Yeah.
Actually, he said that energy is quantized. Okay, packet of energy. Got it? So when this packet interact with electron, okay, so it will absorb this packet.
Yeah.
And this process is the instantaneously. It will not absorb it for a long duration of time, but it will instantly absorb this packet. So that is the instantly instantaneous process. So this point he explained like this. Okay, there are some photon properties. We need to discuss that. Then after that, I will take your question. This is the last point of this lecture. That is the properties of photon.